नमस्ते, मेरा नाम आकांक्षा है। मैं भारत से हूँ और मुझे ड्रॉइडकॉन लंदन में आकर बहुत अच्छा लग रहा है।
Habari, jina langu ni Kendi kutoka Kenya. Nina furaha kuwa DroidCon London.
I know you all must be like, what did they just say? So this is this is me, and my native language is Hindi. This is Kendi, and her native language is Swahili. And if we want to talk to each other, if we in our native languages, then the communication won't be possible, right? So that's why we need an interoperability bridge, which is Google Translate in our case. So this will translate my language to English, which is common for both of us, and she will be able to understand my language, and that's how we will be able to communicate. So basically, interoperability is like speaking one language that all gadgets understand, and it's like a universal translator. And in programming, it refers to the ability of different software systems, technologies, and programming languages to work together and exchange information. And this way, the whole system works, especially in today's world. Like different softwares, they are written in different languages. So if we have interop bridge for interaction, then it will just make life a lot easier, because we cannot just have one common global language, right? So yeah, diversity is important. So let me start with my introduction. So my name is Akanksha Singh. I'm a software engineer at JP Morgan. I'm a Flutter developer and a Women Tech Makers ambassador. I love hackathons. I am a community builder, a speaker, and yeah, that's about me.
And my name is Kendi. I am also a Flutter developer. Besides that, also a DroidCon Kenya co-organizer, and I'm a community builder as well as a speaker, and I lead the Flutter community in Kenya.
Yeah, so that's why we are here to talk about interoperability. As you saw, it's really important to have diverse languages. And when I was working with integrating voice in my Flutter apps, and I wanted to have like Google Assistant with my Flutter app. So when I say, hey, Google, open my Flutter app. So to do that, something that I required was to interact with the Android native side. And that's where I felt it's important to understand and interact with the native components. Uh, for Kendi, you can talk more about AR. She has worked with AR, and yeah.
Yeah, absolutely. So when I was working with augmented reality with Flutter, I obviously needed to like connect to the native side, especially when I was working with the AR kit for the iOS bit. So that means that I needed to connect my application to the native side, and I wish to like play a small video where I showcase like how it basically was trying to access the camera bit. So as you can see, the application is starting, and then it requires me to access the camera. And then when I click on play, it asks you if I need to access the camera. So I have to say okay, and then you're able to see how the augmented reality basically interacts with it. So I feel like that was another example that I needed to work on so that I'm accessing the native side of the platform. Other use cases that we might have are maybe when you're working with the sensors and you need to check your blood rate and heart rate. So basically that also you need to work on the native side to rather connect on the native side. So it's one other use case. Or when you're working with an application, like let's say a banking application, and you need to have facial to open your application, or you need to use your fingerprints to access your application, then that means you need to find a way to access the native side. But how do we go about that with Flutter? But then before we move to all that the native side, we need to at least understand the Flutter's architecture. And we all know that Flutter architecture has mainly three layers. We have the framework layer. So mostly this is the part which developer actually interacts with, because we have the widgets, the material, and the animation bit. And then we move to the second layer, which is practically the engine layer. So the engine layer is the part which your device actually interacts. And as you can see, we have like the platform channel, we have the rendering, and etc. And then the last bit is the embedder. So the embedder is practically the link and the facilitator between the framework, that is the engine, and the device for all the app functioning. And if I may add more, it's also platform specific and is mainly responsible for bringing out each pixel that you see on your screen or the surface.
So now that we saw what the Flutter architecture is and where the major three layers sit in, and we also gave some examples of our experience with accessing native functionalities. So what other advantages do we get by interacting with native components? So the first example, the first thing that we can do with native components is like native APIs is we will be able to access platform specific features. So suppose you're developing a photo editing app or a photo app that requires advanced access or advanced features to access like the manual focus and control to specific hardware features. So that way, if we can easily do that by interacting with native APIs. Another thing is with the native APIs, it definitely optimizes the performance. So if you're building a graphic intensive application, especially like games, so with you can utilize platform specific APIs and low level graphic libraries, and you can achieve better performance with them. We can also leverage existing native libraries. So if we are developing, suppose, a multimedia application, and there might be some existing libraries for audio and the video, so we can utilize them and have better performance. So we can also have a seamless integration with third-party SDKs. So a lot of chat apps, like some chat SDKs are there, which like for iOS or for Android. So it's easier to integrate. And there might be cases when you might not be able to find a package for the functionality that you're looking for. So in that way, like in that case, you can definitely go for native APIs. And it also ensures platform specific compliance and policies. So like in Apple, they have health related apps, they have policies. And the APIs, if you use the native APIs, then you will be able to comply with those policies and make your app compliant to the policies. And supporting background execution and multitasking can also be a bit faster with the native APIs. So those are a couple of advantages of interacting with native components and native APIs. There are a couple of ways that we're going to discuss today. So some of them, like we're going to discuss about platform channels, the Pigeon package, and JNIGen and FFIGen today. So Kendi, why don't you tell us more about platform channels?
Absolutely. So a platform channel is like a flexible messaging API between a Flutter application and the platform hosting the application. So it's how you can communicate with native and the third-party APIs. And when I talk about the platform hosting application, in this case, I mean either the Android or the iOS. And if you're talking about the Android, then there are a couple of languages that you may need. For example, these are the platform channels that supports different languages and the platforms. For example, if we're talking about the iOS, then we have the Swift or Objective-C, and the Android bit we have either Kotlin or Java. And if you're working on the Mac OS, then we have Swift also, Objective-C, and Windows, C++, Linux. Now we have the C language. So what about the web? The amazing bit about the web is that is already compiled to JavaScript on the web. Therefore, there's no need for platform channels. In this case, the interop between the Dart and the JS, it is very possible because all you need to do is just to use the package.js package. And you may ask, now that we have we've defined what platform channels are there any types? Yes, absolutely. We have like two types. We have the method channel and the event channel. And if I may explain more or expound more on what method channel is, this is a named channel that basically processes its messages in an asynchronous way. This means that whenever you have like a particular process that you're working on, let's say for example you're trying to like get the battery level, then that means it's asynchronous and it has to like wait a bit so that you get whatever you want to work. And it's mostly best suited for like small things like probably getting the battery level or maybe accessing the camera and such. And then we have like the architecture of this particular method channel. As you can see here, we have like the Dart code and we have the particular other languages that we want to like access, which is either the iOS or the Android bit. And I would like to like explain a little bit on what it means on different sides. Like we have the main activity. So the main activity on the Android side, basically it's the activity that controls what the application does. And then when we're talking on the app delegate on the iOS side, then the app delegate is effectively the root object of your application. And this works in conjunction with UI application that manages some interactions with the system. And then we have the Flutter View controller on the iOS bit, which attaches to a Flutter engine, which ideally helps to like pass input events into the Flutter and to display frameworks rendered by the Flutter engine that we had earlier discussed. And then we have the Flutter View. The Flutter View on the Android side basically almost does almost the same thing as the Flutter View controller on the iOS bit. All right, and then the second one is the event channel. The event channel is a method channel that processes its messages using a stream, and it's best suited for tasks that need frequent update. For example, if you're listening to your device motion sensor, then this would be like a perfect example. So how do we essentially connect the method channel? So first of all, you need to like create like a constructor. You need to like have like you construct a channel rather. And then when you're creating this particular channel, you need to give it a very unique name, because this particular name for the method channel name, in our case, we're calling it example Flutter native. This is what we're going to use on both Android and iOS, and I'm going to like show you on both sides. So after now writing the constructor, then you need to invoke the method on the method channel, and this ideally is how you go about it. And at the end of the day, we are trying to like get the battery level, and if you don't get the battery level, then you get like a message that shows failed to get the battery level. On the Kotlin side, the method call handler for the method channel. So we have the method, we have the first of all the name that we gave, which is very unique, the channel name, and afterwards we need to like have call the method handler for the method channel, which ideally gets the battery level. And afterwards, then you need to like have the get battery level function, which now fetches the battery level. And afterwards, now that we are already done with the Android side, we go to the iOS side. This is an example of a Swift code, and this is how it looks on the iOS side. Again, the name that we use, the example Flutter native, the way we called it from the Kotlin side, we also need to like implement it on the iOS side, and then we need to like call the method handler for the battery level channel, and this basically how you go about it. And afterwards, you need to like uh, implement this particular function which receives the battery level basically. So after viewing the two examples, you get to notice that the method channel is not inherent type safe, meaning that the correct communication relies on both the host and the client declaring identical arguments and data types. And with this, that means it's very cumbersome, and it's a whole lot to do it. So how do you go about it?
So yeah, do we have any solution for it, Kendi? Because it's very cumbersome, and writing this much code would be a lot for if bigger application. So how about do we have any solutions?
Absolutely. So we can try to like have like a different solution, and we are so happy to get the Pigeon package. So the package basically is like a code generator tool that instead of you having to like write the whole thing on the Swift and the Kotlin, and maybe you don't know how to like go about both languages, then you have the Pigeon package, which is a code generator tool which generates all the code that's needed for communication between that and the native platforms in a type-safe, easy, and effective way. And when we come to the Pigeon package, then this is how it looks on the pub.dev. And we have like steps. The first step is obviously to like get the package, and then the second step is to define the app device handler API. So the above annotation basically is used to specify communication direction, and then you use the host API to configure sending message from Flutter to the platform host, and then you use the Flutter API annotation to configure sending messages from the platform host to Flutter, which is very simple. And then this is just an abstract class that and which we basically just get the abstract classes from the Pigeon package. And then the third step is now you need to run this command. And if I may try to like you know give more input on the input argument, this one is an argument that will be the file we define the API, and then we have the data out, which is in our lib folder, as it's the code we'll actually be using in our application. And then the Java package is the full package name that can be found in application from Android source file. And then we have the Java out. So the Java out is the path to the Java file that will be generated, and then we have the experimental Swift out, which is the path to the Swift file that will be generated, and then we have the object handler out and object source out, which is the path to the object handler. And then the next step that we use is the Android implementation. So in our example today, we are going to go with the Android implementation where we are using the generated Pigeon app device helper file to override the functions. Um, the next step is basically to register the the package into our main activity so that the Flutter application can communicate between the device helper to get all the information that we basically want to achieve. And then this is how you handle it on the Flutter side. And yeah, so we can see like using the Pigeon package basically helps us to like generate this code base even without us having to like write them manually. You wish to take the next
Yeah.
one?
So, as Kendi talked about method channels, and you saw they are not type safe, and that's why we there are a couple of other limitations as well. because we have to write code on the native side, and it increases the development time, and it's harder to refactor as well. And the Pigeon package does help us a bit, but to overcome these limitations, we can do a bit more. And that's why we have foreign function interface. So foreign function interface serves as the mechanism for enabling the invocation of functions from one programming language within the other language. So if suppose our code is written in another language, but it compiles into C, and we can access those functions if it is compiled into C, and then we can access, because we can access those functions in other languages. So the languages, today we're gonna look into the Dart FFI package. So the Dart FFI package allows us to use existing code in C libraries, and it also benefits in portability and the performance, because we can use highly optimized C code. And with FFI programming, you are not just limited to C, because as long as your code compiles into C, which can be like Go or Rust, and you can use the package to access those functions. So Dart FFI example to access the dynamic library. So the native library can be linked into the app either statically or dynamically. So the statically linked libraries are embedded into the application's executable image, and they load as soon as the app starts, while the dynamically linked libraries are distributed in a separate file and folder, and they load on demand. So for a simple example, like a C program to add two functions, we can generate a dynamic library using the command GCC command. So this will generate a dynamic library for us, and if we want to use it in our Flutter side, so we can use the Dart FFI package. We need to give the path to the dynamic library that we generated, and then we need to use the functions to access that path, and we can use the lookup function to look for that function that we want to use, and then we can simply use a C function that we wrote in C++ or C in our Dart code. So that's basically how Dart FFI works. But also to generate bindings, FFI bindings manually, it can be hectic. So why not generate it automatically? So thanks to open source, we have JNIGen and FFIGen, which are Dart bindings generator for Android and iOS. And if we see like what FFIGen and JNIGen do, so FFIGen was introduced 2 years ago. It was part of a Google Summer of Code project, and the person who worked on it, we should give him the credit as well. So his name is Prerak Man, and he worked on FFIGen Google Summer of Code project in 2020, and it was later extended to support Objective-C as well. And it uses libclang to parse the C headers and generate the wrapper code for calling them. The goal of JNIGen is also to provide the similar functionality for the Java libraries. It combines Dart FFI and Java native interface to do that. And FFIGen and JNIGen both work on the basic principle of foreign function interface and to access the methods of C files. But first, both of them convert the native code into C. And JNIGen is for Android, and FFIGen, as I mentioned, is for the iOS bit. So, yeah, so about JNIGen, what it does is we pass the path to our Java classes, and it generates an intermediate C code that is then used for accessing the functions. And yeah, so if we want to use JNIGen in our, just how Kendi showed the battery level, just a simple example to get the battery level of the device. If we want to do similar thing using JNIGen, the implementation, suppose we have this battery utils class, which is basically to get the battery level from the Android side, and we want to generate FFI bindings for it. So what we need to do is the first step is some installation. So you need to have MVN and Clang format. So for different platforms, it can be different. So you might have to check like what installations you need. And after that, you need to add the packages, JNIGen package and JNI package in your project. And then the most important bit of this process is having a binding YAML file. So this contains configurations to be used by JNIGen, and we have to give the paths for the native classes, and let me show you how it looks like. So this is the output path for C and Dart. So this is where the output after generating like these files would go. And we also have add Gradle depths as true. So what this will do is this will run the Gradle stubs before generating JNIGen, so that Android compiled class path is available before execution. And output is where we specify the configuration regarding output file, the paths, and the library name. We also need to pass the list of directory paths where the classes are placed. So this is like it can be different as well. Like so in Java, like you classes will be here, the Java classes. And then we have the classes. Here we specify the list of classes that need to be converted. So I showed you the battery utils class that will be converted. So this is where we define that in the configuration file. So there are a lot of properties that you can have depending on what you're working on. So this is just what I showed, like a couple of things that I have in my configuration file, like the output. You can have output bindings type as well. Either it can be C based or Dart only. So if you don't want an intermediate C layer, you can, if you want just the Dart only code generated, then you can enable that. And yeah, basically it's just about the configuration of the YAML file that you will have. And after you have that YAML file, all the configurations are ready. So you need to run this command to generate the bindings. So when you run this command and it is successful, you will be able to see all the binding files placed in the directories that you defined in the YAML file. So after that you have that, the another step that you need to do is to specify the path of your CMake list text file. It will be the directory where C bindings are placed. So this step will ensure that your C code is compiled into the native library, and Gradle will package this with your app. So you need to specify the path to your C make list file as well. And now that we have done all that, how we can simply access now we can simply access this in Flutter side. So yeah, simply just write the function. We are using the battery level utils, and we can get the battery level status from here, and we will be able to get the battery level, which is quite easy. So yeah, so we discussed about method channels, how pigeon package make generation of code easier, and also looked into JNIGen, which is pretty new. It's in the experimental phase. There are a lot of more things that are being done. But which one to use, and it depends on what purpose you're using for. So foreign function interface is useful when you're trying to utilize platform libraries. You are working with legacy codes. Legacy code is written in like the languages that C or C++ or something. So you need, if you're working with legacy code, you will have to use a foreign function interface. You want to work on, like you're working on a high performance app and you want to optimize the performance. In that case also FFI will help you, and your setup is less platform dependent. So in that case also, and the method channels are best suited for small scale projects that have less code complexity and easy to set up. The Pigeon package is suited for large scale as well as small scale applications. They help us in providing a type safe code, which might be harder for large scale projects to maintain. So they help us in that, and it's easy to set up. And the code generation also saves some development time. So depending on what type of project you're working on, what native APIs you need access to, you can decide on what to use. And to conclude,
Yes. So when we come to conclusion, then platform channel, the Pigeon package, and the FFIGen are indispensable tools in the toolkit of a modern app developer. And in this case, they bridge the gap between different programming languages, they streamline integration processes, and ultimately empower developers to basically create seamless platform performance and feature-rich cross-platform applications. So in this case, by understanding their strengths and nuances, then developers can harness their full potential and continue pushing the boundaries of what's possible in the world of cross-platform development. So yes.
Yeah, I mean, using definitely there are tons of packages, but there can be cases where you want to use native APIs, native components to optimize performance or something depending on your use case. It definitely using methods, method channels, JNIGen, FFIGen, and all that. They definitely empower the cross-platform development by making it more efficient and yeah, they extend Flutter's capabilities for sure. So yeah, that was just about an overview of what interoperability looks like in Flutter, what are different ways you can achieve that, and what are advantages of doing that. So that concludes our talk, and thank you for attending it. Before we end, we want to tell you about another conference that's coming up in November, and it's Flutteristas conference. There are a lot of amazing speakers. We have 20 plus speakers, and the best thing is it will be streamed on YouTube online, so you don't have to go anywhere. You just need to tune in on YouTube, and there are a lot of amazing speakers, Kendi as well. So yeah, do check out Flutteristas conference, and thank you so much for attending the talk. You can connect with us on our social media handles.